end of the day, my dear Razan was up here and she was being a human ring stand. Do y'all remember this? Yeah? Razan was standing up here so bravely, and Harrison was over there so bravely, and the ball bearing went this way, right? And this one fell down, and you remember that you made a prediction as to which one was going to hit the ground first. And we listened just before the bell rang, and what did you hear? What did you hear? You heard balls dropping, but how many? What did it sound like? Really?
We got to hear you.
How did they? We don't have time. You can go back and listen to the YouTube. It's online. You can listen to it again. I want to know what you heard. What did you think? What did you predict versus what did you hear? It went like this, and it went down, and it went down. Which one hit the ground first, friends?
The one on this side. Right. This side.
Okay, Razan, come here. Oh my gosh, I can't change the homework, so we gotta go fast. Harrison, go over there so you can catch the ball.
That's right. Nothing ever touches.
All right. Are you gonna do the flipping, or are you gonna do this flipping? Watch your hand. I just don't want it to hit this stuff. Good.
Neither.
Same. Did you hear it? Same. It is the same time. That was very nice. Good job, you guys. Thank you so much. All right. So what did we hear? We heard one click. So it's good that we're saying this because our friends that are watching this at home are going to say, wait, I only heard one and you said there were two balls. Absolutely, there were two. This is the weird thing. So we had two balls. One of them, oh, look, I already drew it. That's kind of convenient. Okay. One of them's right there and it's falling straight down. The other one that's going down, it starts here. And then what does its trajectory look like, ladies and gentlemen?
Nearly straight.
This one over here? The one that got shot towards Harrison? No. There's a word for it. What's the word? Starts with a P. Parabolic. It was a parabola. It went something like that. So go ahead on your notes really quickly right now and draw that picture. So it's something like this. Something like that. Okay? It was a nice parabolic shape. And I'm going to go ahead and draw that ball a few more times. Maybe one right there. And one right here. And you can go ahead and do this as well. So you've got a nice pretty picture just like mine. Okay? And then once you've got that nice picture, I want you to think about the motion of the ball. Remember when we had this one, the one that went straight down, it started off with how much velocity? Look at the picture. There's no arrow. Zero velocity. Are you with me there? Does this one start off with any velocity?
No.
Yes, Jacob, you say yes. Why?
Because it gets kicked by the thing.
It gets kicked by the thing, right? A force was applied. So it's now moving with some velocity. In which direction, though? Right. In the direction to the right or in the horizontal direction? Okay? Later on, oh my gosh, now the velocity of this thing is going down like this, right? We're just going to follow the arrows, follow the trajectory. And they go like this, but that really is just two pieces. It's really a piece in the X direction. And does it accelerate in the X direction, ladies and gentlemen? Is there anything, once it's been kicked, pulling it or pushing it in the X direction? It's just like the ball that was rolling. Are you with me there? Rolling. No acceleration in the X direction. Okay? So this green arrow are the velocity of the ball in the X direction. The velocity of the ball in the X direction, there's nothing pulling or pushing it, which means the net force is zero. If the net force is zero, tell me about the acceleration. also 0. Vx is constant. Any acceleration in the x direction does not exist. That ball that's going, right, that's going down at this funny trajectory, it starts gaining velocity in the y direction. Are you with me there? And we know that for sure because it hits the ground at the same darn time this one does, doesn't it? Which means that it's got to be falling the same way as the other one was falling. Are you with me there? They're falling at the same rate. The one over here's just got a kick. It got a kick in the x direction. So it's moving in the x direction at the same time it's moving in the y direction. It's weird. But let's draw the picture. Let's draw the picture. It's got 0 there. It's got a little bit here. It's got a little bit more here. It's got a little bit more here. It's got a little bit more there. Okay? In the y direction, Vy is not constant. Tell me about the acceleration in the y direction, ladies and gentlemen. What's going on with the velocity? Or sorry, did I say acceleration or velocity? I can't remember. I don't know. I'm going to say acceleration now because that's what I wanted to say. Tell me about the acceleration in the y direction. Does it change or does it stay the same? The acceleration? Tell me about the acceleration of this one as it's falling. The acceleration does not change. You with me there? The acceleration is just the acceleration of gravity. Same thing that we measured when we were outside. Okay? The acceleration does not change. The acceleration does not change. The acceleration in the y direction is just negative 9.8 meters per second squared. It does not change. Huh. We doing okay so far? I've got one more little thing to throw your way. Where did my frog go? Oh, is he sitting over here? He is. Let me ask a quick question. What would happen if I take the frog and I throw him in the air? Whoa, not like that.
Drop.
And then he goes like this. What would the velocity vectors look like if I throw him in the air and then he comes back down? What are the velocity vectors going to do? Big, small, small, big. With a 0 at the top, right? Did you guys all catch that?
Yeah.
It's going to go big up, smaller, 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 0. Bigger, 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 right? Yeah. What are the acceleration arrows going to look like if I throw him up in the air? Oh, where do the acceleration arrows go? Do they point up while he's flying up? Which way do the acceleration arrows go? Down. Do they change in size? The acceleration arrows do not change. You with me there? Acceleration does not change. Let's draw that picture. Let's draw that picture. If I throw the frog in the air, so here he is at the bottom. I'm just let him go, and his velocity's going like this. And a little while later, it's going like this. And a little while later, it's going like this. And a little while later, it's going like that. And a little while later, it's stopped. Okay? The velocity changes. Okay? And it's always decreasing. What does the acceleration arrow look like for this one? Same. And where does it go?
Towards the earth.
Towards the earth. It points down. There's a force, right? The force that's causing the acceleration. The force goes this way, and it goes this way, and it's the same length every single time, the whole darn time. The acceleration does not change. And then as it falls back down, it's the same thing we just did. So I've got one more question for you. Are you ready? Okay. Are you ready, Harrison?
Yep.
Come stand right over here for a second. Or you can sit because you're lazy, right? Got it? Okay. So now you got to watch the trajectory of the frog. You ready? Here we go. What did it do? What did it do? It flew, yes. Tell me about the trajectory of the frog. What does it look like? Starts with a P.
Parabola.
Yeah. Yeah. It's a parabola. Let's draw it. Goes up and comes back down. Hey, wait, you saw that when we were out on the football field, right? Oh, yeah, when we shot those rockets, it's the same darn thing. So here we go. It was, but they still followed a parabola. It was a skew parabola. Think about that. That's part of your homework for tonight. I will see you guys on Monday. I want to say thank you very much for working hard, for trying this out. It's good stuff.